Okay, you guys, this is a little bit of 10.5 if you look, and that's where your homework is. It's talking about the area, and 11.6 is talking about volume of non-rigid transformations. I call it congruent and similar solids. What you're going to see is we're going to be setting up ratios if our polygons are similar, they have scale factors, and blah, blah, blah. And I will, again, emphasize where the mistakes come up that people make. Okay. So, obviously we know that something is similar. It means the exact same shape, but different sizes. And then this is really important. If the ratios of all, has to be all of them, the corresponding linear measurements are equal. And what I mean by linear measurements is the altitudes, any sides, the slant height, the radii. That's going to be our scale factor. And if they're all equal, then then our solids are similar. And I will show you what I mean. And we're going to be working mainly with the scale factor. So the scale factor is dealing with the ratio of their sides. So the scale factor is going to be the ratio of their sides. And if they're the same measurement for both comparing, then the solids are similar. Obviously, if they're congruent, means same shape and size. If the ratios of the corresponding measurements are 1-to-1, because what we're going to do is we're going to simplify them. Then obviously the solids are congruent. The scale factor is 1. So here's what we're going to work with. If two polygons are similar with some scale factor AB, so AB obviously is just a number. So I'm going to write it like this. SF is your scale factor, because you're going to see me write it like that, is A over B. So if I have two polygons, I don't care, and the radius of one is 5 and the other one's 6, it's 5 over 6, A over B. Now I'm going to put a little star. All ratios must, this is the most important thing, and this is what people forget, and you'll see why, be simplified first. So obviously all of our ratios must be simplified. So here is our scale factor. If, and again, it'll make sense when you guys get the examples. If I'm asking you to find the surface area of something, what you're going to do is for the surface area or any area, you are going to be taking the scale factor ratio. So let's write this. Obviously, it's a ratio. You're going to take your scale factor ratio, and you are going to square it. And that is how we're going to end up solving it. Again, you're going to see in a moment. So you guys will take that, and then you will square it, and then we can go from there. So just remember, and the easy way to remember that is surface area is always in squared. Now, if I'm asking you for the volume, well, think about it. Volume's in the form of what? Cube. So what you'll take is the scale factor. Again, everything stems from the scale factor. And you will take their values and you will cube them. You know, and it works both ways. If you have the volume and you want the scale factor, you're going to take the cubed root of it. So they go both ways. Same thing, if I give you the surface area or the areas, if you want the scale factor, you're going to square root it. So you have to make sure you understand. You obviously can definitely go both ways from here to here. How do you get there? But it's super important that this understanding, and you'll see how that's your scale factor. If we're dealing with surface area, we square them. If we have them, you square root them. If you want volume, we cube them. If you want the scale factor, you cubed root them. Okay, so let's see how some of these examples kind of, what do they mean? So on your homework, you have something similar. That's why I wanted to go over this. So it says, determine whether each pair of solid is similar. Similar means the ratios are equal. Congruent, obviously, if it's 1-to-1, which means the same, and neither is neither. If they're similar, state the scale factor. All right, so for the first one, you have to do the comparison. So here's what I would say. I'm going to start with this one. So 4-to-3. So obviously, if you put 4 over 3 in your calculator, I always just stick with the decimal. You know, we get 1.3 repeating. All right, let's now put the the height. Let's figure out what 14 over 10.5 is. So 14 divided by 10.5 is 1.3 repeating. The fact that they're linear measurements, radius and height, their ratios are the same. And they're the same because if I put this in, this would simplify to 4/3. They both simplified 1 to 3. That's their scale factor. So first of all, these are similar. And you're going to see me write scale factor is 4 to 3. Or you guys obviously can put it as 4/3. Doesn't matter. Okay? For this, now if you're wondering for the second one with the circle, the spheres, you're only giving one measurement. Well, here's the thing with the sphere. First of all, they're circles, and all are always similar, right? Think about that logically. How can they be not similar? They're all spheres. So they're all going to be similar, and in this case, the scale factor, I'm going to always just go left to right. I just take the two radii and put them over one another, 9.4 divided by 2.35, and it's a 4-to-1 ratio for your scale factor. Please make sure you guys are putting two numbers for scale factor. If you want to put 4/1, that's fine, but normally it's seen like that. All right, next one, your pyramids. All right, so let's compare. 8/12. Well, I like to just do decimals to start with to figure out they're the same. It's 0.66, repeating with the 7, so 2/3. Let's see about 5 rad 2 over 7 rad 2. Well, the nice thing, you can cross off the rad 2's, and 5/7, just so I can visually show you guys, is 0.714, ... They are not the same. So this one is, oh my God, I don't know what I was gonna write. Neither. Okay, for them to be congruent, it's just giving you guys the same measurement. Okay, so that's like the first part in your homework. That's just kind of understanding. Now let's take a look at some examples. I did give you a bunch of examples, but the examples, they go pretty fast because this is an easy topic, but people tend to mess up. Okay, so more examples you guys have, the better it's gonna be. So it says mirror balls are spheres. We all know spheres are similar with reflective tiles. One sphere has a diameter of 4 and the other 20. The scale factor, well, it's 4/20, but again, very important is this. You must simplify everything, and there's going to be a reason, so make sure everything is simplified. So your scale factor is 1/5. Find the ratio of the surface area. The ratio, again, you're not finding the actual surface area. We're going to work with that, and that's why we're going to work with the ratios. So again, we don't know what, here's the diameter of 4/20 in real life. But we're going to say it's 1/5. That makes sense. It's a ratio. So the surface area, I don't know. And if I were to calculate this, you can see how it works. But an easy way is just for surface area, you square the scale factor. So again, scale factor. Surface area, we square it. 1 squared is 1. 5 squared is 25. So that would be your surface area's ratio. And then the volume, everything stems from the original scale factor. You take that and you cube them. So it'd be 1, the cubed root of 5 is 125. And that would be your volume scale factor. You need those numbers. They are so important because, and it all depends on what I'm asking you. If I'm asking you to work with surface area, use this, and I'll show you. If I'm asking you to work with volume, use that. Again, these are ratios. You have to understand they're the ratios. They're not obviously the numbers. Okay, enough of me chatting. Let's take a look at our examples. So we have a bunch, like I said, but they go fast. Okay, so the things you want to look for. They're similar. The ratio of their sides. So when I'm talking about, remember, sides, altitude, slant heights, radii, anything that's a linear, this is my scale factor. So I want you on your paper to write scale factor, and it's 2 to 3, so we're going to put it as proportions because we're going to end up cross-multiplying and solving. So then it says the surface area of the larger prism is 1944. What's the surface area of the smaller prism? So here's the deal. Because I am working in surface area, you need the surface area's scale factor to be able to figure out the actual surface area of the smaller rectangular prism. As I told you, the main thing people forget is all the scale factors, depending if you use volume or surface area, have to be converted into the same quote-unquote units, meaning if I'm dealing with surface area, I better take those values and square them. and then continue. If I'm talking about volume, I better take my volumes ratio and then continue. So people end up using this. No, this is the scale factor of the linear. So we want to deal with surface area. So you need to take the scale factor and you need to go to surface area, so you need to square them. So it'd be 4/9. Now I can set up the proportion because this is in surface area and this is surface area. The larger one obviously is the larger one of these numbers, so it goes on the bottom. X cross multiply. So the surface area of the smaller prism, look at this, without even calculating, is 864 fine centimeters squared. Done. It's that easy. But again, the most common mistake I've seen is people take this number and they set it equal to this. And that is a huge mistake, and it's happened over and over and over again. So write yourself the notes. Like if you want surface area, everything must be in terms of surface area. That's the scale factor. I know I'm repeating myself, but again, those are the mistakes. So let's do another example. Two cylinders have a radii of 15 and 6. Okay, so remember, this is our linear measurements. So our scale factor, 15/6, or 6/15, it doesn't matter, whichever way you want to do it, just make it correspond. And again, everything must be simplified. So if we divide this by 3, we have 5/2. That is my scale factor. So maybe you guys should do that. What I'm doing is like box in the original scale factor. Now, we're talking again about surface area. Maybe you should do this as well, so it's like a visual for yourself. And it says if the surface area of the large is 2592, what's the surface area of the small again? Okay, original, we need to be in surface area. Surface area means you want to square, so get in the habit of doing this so you remind yourself. 25/4. Now we're going to take the large number and we're going to put it on top. Cross multiply, and I did not do this one, so give me 1 second. So 4 times 2592 divided by 20. All right, so divide by 3, make sure 5 divided by 3 is 2. Square, 2592. So we get the surface area would be 414.72 inches squared. That's it. It is that easy, but it is that hard where you guys take this number and you set it equal. Okay, let's go on to another one. Oops. Like I said, I have a bunch, but the examples will be fast and I'll stop talking after a little bit. All right, so here we go, the ratio of the two sides. Okay, so here's our linear. So on your paper right away, write the note, scale factor, 3/4. Put a box in it because you're not going to be using that number. The smaller cube has a volume. All right, here we go. We're dealing with volume. Write yourself that note. Which means this must be in terms of volume, which means you cube it. 3 cubed. Now, whoops, 27. That's a 27. 4 cubed is 64. Now I'm okay because I'm working with the same measurement. This was linear. This is in cube. Smaller, so smaller goes on top. X cross multiply. Okay, so you get the volume of your large cube is 1728. That's it. Now, careful. I'm asking you, I went a little bit further and I didn't realize it. What is the length of the side of a cube? Well, if this is the volume, we should all remember what is the formula for a cube. So volume, it's a cube, so that means it's a prism. If you remember for prism, it's length times width times a height. And all of them are the same. So side cubed is equal to 1728. Remember in your calculator, you raise it to the 1/3. Use like that caret key to the 1/3. And here's what you guys get for a side. Okay? Okay. So let's continue. Next, 2 similar pyramids, so slant heights, 6 to 12. So that's your basic linear, 6 to 12, which we want to make sure we simplify. 1 to 2, box it because you ain't using it. The volume of the large, so we're working with volume again. Write yourself that note. So we want this to be in terms of volume, so we have to cube it. 1 cubed, 1, 2 cubed, 8. That's it. Okay. The volume of the large is 548. Wow, that was pretty bad. 548. What is the volume of the small? So here we go, x. And then we cross multiply. Good if I can type in a calculator. And your volume is 68.5 inches cubed. Here you go. Okay. All right, let's look at number 9. So number 9 says 2 spheres have the volumes. Okay, so now I'm doing the opposite. So I'm just going to star this one because we're going to go your opposite way. So I told you a bunch of examples. 2 spheres have a volume of 36 pi and 288 pi. Fine. What is the ratio of the radius of the small to the radius of the large? And then what's the surface area? So since I'm asking you for the ratio of the radius, what the question wants is, hey, what is the scale factor? First. And so it's the opposite of what you guys did here, where I gave you the scale factor and you had to go to volume. So think about it. If you have to go to volume, you cube it. If you want to go back, you cubed root it. So watch how easy this one is. So here's your volume, 36, well, that was weird, 36 pi over 288 pi. Remember, star, simplify, cannot stress this enough. First of all, we cross this off. Now, here's a perfect reason why I emphasize to simplify. If you have volume and you want right now the original scale factor, right, as I just asked you, you want to cube root that. Well, the cube root of 36 does not exist. Very important. So you might sit there and be like, huh, and yes, this is what people do on the exam, and then you give me weird, funky answers. But as I told you, you need to simplify. When I simplify this, 36 goes into 36 actually once, and 36 goes into 288 8 times. This now is my volumes ratio. And now if I want the scale factor, again, you're going to do the opposite. If this is cubed, you're going to take the cubed root, or in your calculators, you raise it to the 1/3. The cubed root of 1 is 1. The cubed root of 8 is 2. Here is your scale factor. Again, or think to yourself, 2 times, or what number times itself 3 times is 8. So I'll just review that again. We're not done with the problem, but just to understand, I gave you volume. In your head, you think volume, you're cubing it. Okay, so if you want to go the opposite way, you cube root it. But this must happen. Simplify. Perfect example of why you have to. If you don't, you're going to get me a funky number and everything's wrong. When I simplify, I work it. So here's the surface area. Now it wants the ratio of, here's your scale factor ratio. Now it wants the ratio of your surface area. Well, you take the scale factor, and what do you do to get the surface area? Square it. So the ratio is 1 to 4. 1 over 4, 1 to 4. I don't care what you guys tell me. Okay? Please make sure you understand that. That's where people make the mistake. All right. So we have a bunch more to do. How many more did I put? I think I put 15. Okay, so we're on 10. Again, multiple examples. So what I did here, and these will help you with like some of the last problems, is we're going to be talking about volume and surface area together. So you have to make sure you're reading, and you have to make sure you're in the right measurement. So let's do it. 2 spheres have a surface area. Okay, so I have a surface area and I have a surface area. So right here, I'm going to write my notes down because there's a lot of words. Surface area of 100 pi, 16 pi. What is the ratio of the volume? Okay, so if you think about this, I have surface area and you want volume. You cannot go from surface area to volume. You first have to go to the original scale factor ratio. And then from the scale factor ratio, we will go to volume. So just like we did up this one, I kind of broke it down to help you. I'm not going to do that. It's going to go right to like just telling you what's the ratio of the volume or the surface area and vice versa. So you have to know, you have to go like this Or if I give you volume and you want surface area, you will go like that. Kind of like when we did, remember our 30, 60, 90 stuff? All right, so here we go. First thing, what do we have to do? Good, say it, simplify. 100 over 16, we can simplify by dividing everyone by, 4. So we get 25 over 4. Great. Now, we want the original scale factor ratio. If this is surface area, to go to scale factor, you square root because it's the opposite. So it's 5 over 2 is the original scale factor. And now we want to go to volume. So to go to volume, you cube it. So volume would be 125. The ratio would be 125 over 8. You want to write it as 125 to 8. It does not matter to me. Just please make sure you're in the right measurement. So I recommend you doing that. Do the things that I do. You guys know I don't do anything extra. I do things to help you out. Okay, number 11. 2 cubes have a volume. Okay, so let's write this down. Volume, you got 64 over 216. I want to know surface area, small to large. Okay, so small to large. So volume, can we simplify 64 over 216? I believe you can if I divide both by 8. You get 8 over 27. So again, simplify. 8 over 27. So these stay together. Now, remember, you want to go to surface area. It's just like we did above. It's just, scale factor. It's just like we did above, except obviously from surface area, you get it. All right, so from volume to go the other way, you guys have to raise it to the 1/3. Or another way, some of your calculators do it. You're doing the cubed root because it's the opposite. Cubed root of 8, 2. Cubed root of 27, 3. That's your scale factor. It's the most important thing. You got to get to that middle. Then we want surface area, which means we square. So 4 to 9 is the ratio of your surface area. That's it. Hopefully it makes sense. Okay, number 12. 2 fine, they're similar. The surface areas, so I'm going to write this down so I don't have to keep rereading or miss anything. It's 24 over 96. And again, I want the volumes. Again, I know this is repetitive, so if you get it, you can kind of move the video along. Simplify, cross these off. You can divide both of these numbers by 24. You get 1 over 4. Okay, so that is your surface area. We want to go to scale factor. So we square root of 1, 1, 4, 2. Scale factor. We want to get to volume. Same thing. Hopefully you guys are catching on. 1 to 8 is the ratio of the volume. Again, we haven't found anything. So none of these problems that I've done right now with you, you're going to. The 10, 11, 12, never asked you to find their volumes, or specifically, I'm just asking for the scale factor because, yep, you guessed it. Now we're going to be finding the actual lengths of them. All right. Here we go. 3 more and you're done, you guys. And then you finish all the volume. All right, so you got to read carefully. 2 prisms are similar. Great. The height of the first prism is 6. So you have a height of 6. The height of the other one is 3. If the volume is 810, what's the volume of the other? So I'm going to star these 3 only because these ones we tend to make the mistake with as well. So because I want volume, you got to be in volume, correct? What I gave you was 6 over 3 is my scale factor. It's a linear measurement. First of all, let's simplify. You just get 2 over 1. Remember, you need 2 numbers. So this is my scale factor. I probably should have done these after 9, but that's okay. We're fine. So we want to be in terms of volume. Okay, so we want to cube. 2 cubed is 8. 1 cubed is 1, and now we can solve. 810 is the volume of the first. So put the 810 here, put the x here, cross multiply, you get x equals 101.25. So much easier than me having to sit here and find the actual volume of the other cube. Oh yeah, these are similar to 1 through 8. Oh well. Yeah, I'll fix it for next year. All right, next. Two similar solids, they have their volumes. Okay, so cylinders. 670 over 640. Here we go again. Let's simplify that. You can just cross that off. So 27, this is scale factor, over 64. The height of the larger is 10. Find the height. So, I'm sorry, I read too fast. I'm in a little my own world. This is your volume. And I'm asking you guys for the heights. So I'm asking you for the basic scale factor. So the larger is on the bottom. What's the height of the smaller? So again, here we go. We're in volume. We want to go the opposite way to get your scale factor. If it's 27, you're going to cubed root it like that. Or you guys are going to cubed root it like that. Cubed root is 3. Cubed root is 4. Cross multiply, you guys get x equals a height of 7.5 inches, whatever feet. Really easy when you have all that information. Okay, last one. I know you're so excited. I'll have to fix these again. It's bothering me. So I got surface area. So surface area, I have 98 over 18. Let's simplify the surface area ratio. If we divide both by 2, we get 49 over 9. That's your surface area. I don't want to do that with the arrows. Equals. They're talking again about linear, so you want the basic scale factor. So the width of the small, well, I should have done like this. Well, I'm going to cross it off. Small's on the bottom. The width of the small is 9. Find the other large. Okay, so we want to get to scale factor, so we're going to square root, 7 over 3, cross multiply, 21 centimeters. Okay, hopefully that was easy. Now, just to summarize, determine if the solids are similar. You set up a proportion. To find the missing measure, set up a proportion of the corresponding dimensions, cross multiply and divide. To find surface area, set up the ratio of surface area. So again, you got to get the ratio of the surface area to the squared. The ratio of the linear measurements is my basic scale factor. Then you cross multiply and divide. To find the volume, you do the same way, except we cube it. Now on your homework, there's a few problems. I think it's 20 and 21, where they ask you to they give you the picture, like they give you two solids and they give you measurements of all of one and not all of the other, and they want you to find the volume and surface area. So go back and review that. You have to first find me whether it's surface area or volume, find it fully of the first picture. So you have to do your calculations. And then once you do that, you set the scale factor from one to the other, and then put the actual volume under one and continue from there and so far for the other one. So 20 and 21 are your tricky ones, but you guys should be able to do them. You just got to use that brain of yours and think. All right, you guys, nice job. You finished all of your volume, and I will see you soon. Bye.